Homework 10, Quadratic Functions, Video 6, Maxima and Minima. The word maxima as a noun is a plural of the word maximum, and the word minima as a noun is the plural of the word minimum. It's like bacteria, bacterium. So what is a maximum and a minimum? Well, a maximum is a point on a graph whose y-coordinate is greater than the y-coordinates of nearby points. Let me show you what I mean by nearby. Let's say we had a graph that looks like this. We don't, but let's say that we did. And let's say I draw that graph just a little bit larger for the benefit of those watching this video. We'll do it over here. This graph has one and only one maximum, and it is here. Why? Because if you look at the points near it, so let's just put a box around here, the y-coordinate on this point is higher than any y-coordinate around it. Now, it's not the highest y-coordinate on the whole graph. There are points over here whose y's are higher. But it's like if you just look at a portion of the graph, a neighborhood if you will, it's the highest point. Is this point a maximum? No, because if you look nearby it, it is not the highest y-coordinate in that box, no matter how small you make that box. As long as this point is not on the boundary of the box, there will always be a higher point. There's a more technical definition involving intervals, but visually I think it's obvious what a maximum is. You could also define a maximum as a point where a graph switches from going up to going down. And similarly, without writing the whole definition, a minimum is a point on a graph whose y-coordinate is less than the y-coordinates of nearby points. Do you know where the minimum on this graph is? Right about there. That's a minimum. Why? Because if we take a snapshot of the graph around that point, the y-coordinate of this point is less than the y-coordinate of every point near it. Now, it's not the lowest point on the graph, there are lower points over here. But as long as you can zoom in and be the lowest man on the graph, or the highest man on the graph, or woman, then you're a maximum or a minimum. So no other point would constitute, because if I take any other point like here and put a box around it, the y-coordinate of this is not the greatest y-coordinate in the box, and the y-coordinate is not the lowest y-coordinate in the box. Another way of thinking about a minimum is the graph switches from going down to going up as you're moving from left to right. So what does the concept of a maximum and a minimum have to do with quadratic functions? Well, the vertex of a quadratic function must be a maximum or a minimum, depending upon which direction the parabola opens. For example, we already calculated the vertex of this parabola. It was 7/2, -9/4. We also know this parabola opens up because the a is positive, which means the vertex is the minimum. So we can say that this function has a minimum value of y equals -9/4. That is the lowest value that function obtains. And unlike the previous example, this is not just the lowest y value locally, it's the lowest y value on the entire parabola. There would be no points lower than that. You can also say where a minimum or maximum is by saying its x coordinate. So it would be correct to say that this function has a minimum value of y equals -9/4 at x equals 7/2. What about the other function that we analyzed? -3 times the quantity x minus 1 squared plus 7. Well, we know this parabola opens upside down. It was a fairly skinny parabola, but the fact that the leading coefficient is negative means that it opens upside down. That's a maximum at the vertex. So this function has a maximum of, I believe the highest y value is 7, and that happens at x equals 1. So if you go in the previous video, or if you drew the graph from the end of the last video, and look at that parabola, at x equals 1, this thing hits its high value at 7. So every parabola has a maximum or a minimum, and you can actually predict which one it is without doing a lick of work. If the leading coefficient is positive, the parabola opens up, therefore there is a minimum value. If the leading coefficient is negative, the parabola opens down, therefore there's a maximum value. Just remember that as adjectives, the words minimum and maximum are describing y values. Where they occur are the x values. So why is this important? Well, in life, there are things that we try to maximize and minimize. We try to maximize how much money we earn. We try to minimize time wasted. If you're in a business, you're trying to maximize profits and minimize expenditures. Some functions are really messed up, but quadratic functions are very predictable. So if you have any real-world situation that's modeled by a quadratic function, then you can anticipate or calculate how to maximize that value if the quadratic function represents a parabola opening down, or how to minimize that value if the quadratic function's parabola opens up. So we're going to look at some examples where in real-world situations we can model them with quadratic functions and then find a vertex and interpret it in the context.